Factorial notation and summation notation is what we're going to deal with next. Factorial notation, you've probably seen it before. That's when you have a number, an integer usually, or a whole number I should say, with an exclamation point. That English term or that language symbol is actually a mathematical symbol for us. What that means is take the original number, n, multiply it by the next number lower, multiply it by the next number lower than that, and keep doing that until you get all the way down to the number 1. That's factorial notation. So an example would be like 6 factorial. 6 factorial, if we expand it, would be 6 times 5 times 4 times 3 times 2 times 1. And if we multiply all that out, believe it or not, we end up with 720. One of the things about factorial is the numbers get very large very quickly. So what I want to do now is I want to take a look at how do we work with factorials. Let's pretend we've got a question like 6 factorial over 2 factorial times 3 factorial. Now, the mistake, what it's not equal to, is to think that on the denominator there you can multiply the 2 times the 3 and get 6 factorial, and then cancel this all, making it equal 1. No, that is not correct. Do not ever do that. You can only do cross-reducing once you're in full multiplication, and that's not what's going on here. This is factorial. So let's expand it out and see what we get. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Now that we're in all multiplication, now we can start doing some reducing and canceling. And what I want you to notice is the 3, 2, 1 right here. All of these. And that in the denominator comes from this guy. Notice that is the larger of the two. And that's the one I want to focus on, because the way to work this is to realize whichever one is larger that you're going to be reducing, take this one down to that. Don't write 3, 2, 1. Just stop at 3 factorial, because that still represents 3 times 2 times 1. Leave this as 3 factorial, and since they're the same, they can cancel out now. Now we can reduce the 2 and the 1 with either the 4 or the 6. It doesn't matter which, you'll end up with the same answer. And so we end up with 60. Notice that 5 times 6 is 30, times 2 would be 60, or if we would reduce this, we would add 3 times 5 is 15, and 15 times 4 would be 60. So that's how we work with the factorial notation. What I want to do now is show you a little bit more tough problem. Let's look at a bigger one. My bad on the color there. Let's back that up. What I want to do is I want to show you one that looks scary, but it really isn't. 201 factorial over 199 factorial. Now it looks like you're going to be writing a lot of numbers out to expand that. But if you think about what we did right here, it's really not that bad. I'm going to expand 201 factorial out, but I'm only going to go until I get to the denominator factorial. And then I'm going to leave it, because this is still the same as 201 factorial. It's still 201 times 200 times 199 times the rest according to this. So I can go ahead and stop there. On the bottom, I'm going to leave this as 199 factorial, so I can now cancel those out. And realize now all we've got to do is multiply 201 times 200. So it makes the problem a lot easier. And believe it or not, we end up with 40,200 for that one. So there's your factorial notation. What I want to do now is I want to show you summation notation. Summation notation, you've seen this before as well. Summation notation is where we use the capital Greek letter sigma. Looks kind of like that. And we're going to have an index of summation down here. That's going to be some variable. And you're going to have your lower limit, which is what this is equal to. In our case, it's going to be 1. Then you're going to go as whole numbers from this lower limit of summation to your upper limit of summation, whatever you put for n. Then here, you're going to have an equation in this variable. So we'll call that a sub I. Well, what summation notation means is to go ahead and take this equation and start with the 1. So a sub 1, whatever answer that would be, plus, remember we're doing summation. Plus the next one, whatever you get, which would that be a sub 2, plus a sub 3, plus, and keep doing that all the way until you get to the nth term, this guy. So let's do an example of this. Let's expand one out. Whoa, what's going on with my pen there? Let's go ahead and expand this one out. Let's say k equals 2. And that is our lower limit of summation, and our index is the letter k. Our upper limit of summation is going to be 4. And our, what's going on with my pen? 4. And the equation is going to be k factorial. So we can practice that again. Okay, so here we go. We start with 2, then we're going to do 3 and 4. So we're going to find 2 factorial plus then 3 factorial plus 4 factorial. So I'm taking the 2, putting it in the equation for k, then the 3 in the equation for k, and the 4 in the equation for k. If we expand these out, we get 2 times 1 plus 3 times 2 times 1 plus 4 times 3 times 2 times 1. Well, 2 times 1 is 2. 3 times 2 times 1 is 6. And 4 times 3 times 2 times 1 is 24. So in the end, we end up with 32. That is the summation for this problem. It equals 32. So, as you notice, we can use other letters than I, and we can start at other lower limits than 1. Okay, so make sure you're aware of that. The last thing I want to do is I want to share with you 3 properties of sums, of summations. They're pretty obvious, but it's a good idea to take a look at them. So the first one, if we start with I from 1 to n, and we have some equation a sub I, and we multiply that by a number c, we can pull that number c out to the front and just simply do the summation from 1 to n of the equation. And then once you get your summation answer, multiply it by c. The reason is each of these additions are going to be multiplied by the c, so it's just like distributing the c in. Next one I'd like to look at is very similar. It's about addition. It's also a summation from 1 to n. And this one we're going to have the equation a sub I plus a different equation, b sub I. So we can basically break those two equations apart is the idea. So we can do the summation of I to n for the a sub I equation, and then we can add that with the summation of I to n of the b equation. And believe it or not, the third one is almost the exact same thing here, except it's subtraction. So I'm not even going to worry about that. We'll put the subtraction there. It works for subtraction as well. So there you go with the properties of summation. I wanted you to see those before the homework. I wanted you to see the factorial notation because I know you're going to see that again. And we'll talk in video conference class, folks. Have a good day. Have a good evening.